pretty simple name, but a super powerful job. Simple Network Management Protocol, or as we all know it, SNMP. This thing is truly the unsung hero of network management, just quietly working away in the background. At its core, SNMP is basically a language. It lets a central station, we call it a network management server, ask your devices all sorts of questions. Hey, how's your CPU load? What's your memory usage looking like? How much traffic is flying through this interface? It's how you get that incredible bird's-eye view of your entire network's health.
Now, SNMP comes in a couple of main flavors. You've got version 3, which is the modern standard. It's got all the bells and whistles, robust security, authentication, encryption, the whole deal. But then you have the much simpler version 2C. And while V3 is definitely more secure, V2C is still everywhere. I mean, everywhere, just because it's so darn easy to set up. So for today's explainer, we're going to focus on V2C and how to do it right, and as safely as we can.
Okay, enough theory. Let's get our hands dirty. What's the absolute bare minimum command you need to get SNMP up and running on a Cisco device? This is it. This one single line of code is your ticket to the show. If you type just this into your Cisco device, you've technically enabled SNMP. It's the foundation, the starting block that we're going to build on. So what are we actually telling the device to do here? Let's break it down. That first part, monitor raw, that's what's called a community string. The best way to think about it is like a simple password. Any management station that knows this password can talk to the device. And that RO at the end, that stands for read only. And this is absolutely crucial. It means the server can ask for information, but it can't change anything. It can look, but it can't touch. So that basic command works, sure, but it's kind of like leaving your front door unlocked. I mean, anybody on the network who guesses that simple password can get status information from your device. We can do so much better, and it only takes one small addition. Just look at the difference here. On the left, you've got our basic command. It's open to anyone who knows the community string. But on the right, see that? We've added an IP address. This is the address of our trusted network management server. By adding that one IP address, we've basically hired a bouncer for our device's front door. Now it doesn't matter if someone else on the network somehow gets the community string. If the request doesn't come from that one specific IP address, 10.10.10.50 in our example, the bouncer just says, "Nope, you're not on the list," and turns them away. It's a simple change, but it's a huge boost for security. Okay, so our connection is more secure. That's a great step, but we can also make it way more useful. See, a really good configuration doesn't just give you data, it gives you context. So let's look at how to tell your management system who this device is, where it is, and, most importantly, how to make it shout when something bad happens. These two commands, trust me, they are absolute lifesavers for anyone managing a network. Why? Because when you get that alert at 2 a.m., the last thing you want to do is dig through spreadsheets to figure out which device is screaming for help. This tells you instantly, oh, it's the one in Data Center 1 on Rec 7. And if you need to call someone, the contact info is right there. It turns your monitoring system into a real inventory system. So far, everything we've talked about is the management server asking for information. We call that polling. But what if a really critical interface goes down? You don't want to wait for the server to ask about it 5 minutes later. You want that device to scream for help immediately. And that's exactly what SNMP traps are for. And setting up these proactive alerts is incredibly simple. It's really just a two-step process. First, you have to turn on the feature itself, kind of like flipping the master power switch for traps. And then second, you have to tell the device where to send those alert messages when they happen. And here's what that looks like in the config. That first command, SNMP server enable traps, that's our master switch. It just tells the device, hey, get ready to send alerts. The second command, SNMP server host, that defines the destination. It's us telling the device, okay, when something happens, send a trap message to the server at 10.10.10.50 and use our monitor RO community string to do it. Now, your device doesn't just answer questions. It volunteers critical info all on its own. All right, we've layered on security, we've added context, we've set up proactive alerts. Now,
let's put all those pieces together into our final recommended configuration script. This is the big reveal.
And here it is, our complete starter script. Now, this isn't just a random collection of commands, right? It's a whole strategy. We establish that read-only access, but we lock it down to our trusted server. We add that vital context for inventory and troubleshooting, and then we enable those proactive alerts to be sent to that very same server. Together, these 5 lines create a really secure, informative, and responsive monitoring baseline.
And just like that, there you have it. We started with just a single, simple line of code. And by layering on security, then context, and then alerts, we've built a robust and genuinely useful configuration that you can actually deploy with confidence.
So we've just given your network device a voice. We've taught it how to speak to your management system. The only question left is, with all this new visibility at your fingertips, what are you going to ask it first?